Today we will make a simple turret in Unreal Engine 5. So the turret can look at us and it has two modes. It is either searching the target or it is attacking the target. So right now it is searching the target, and if we come into its vision, it will start attacking us. So right now it is attacking the target. Let's see how it works. Let's create a new project in Unreal Engine. Under Games, I will select third-person template. And I have also included the starter content in my project. Let's name the project something like Turret Project. I'm using a turret model from Sketchfab. So this is the Lovejoy turret model that I'm using, and it is a Valorant fan art. It is under CC attribution license, and if we download it, we can see the credit details. So this is the credit for the creator. I have already downloaded the model. So let's import the model to our project. In the content folder, I will make a new folder. I'll call it turret. And with this folder open, I will open the turret that we downloaded, and from the source, I will drag and drop this Lovejoy turret FBX. I'll say import all. It shows some warning, but it still works for me. Right now the model is imported, and we need to still import the textures. So in the textures folder, let's select all and drag and drop here. So we can see that our textures are also imported. Now we need to fix the materials. So first let's fix this muzzle 1 material and then the muzzle 2. So first let's open the muzzle 1 material. And we also need this muzzle 1 texture. This is albedo, and first let's delete this parameter. And we also need to change something here. Blend mode opaque. Let's say the blend mode should be masked. And then we can plug this alpha to the opacity mask. And we can plug this RGBA to emissive color. But before that, we need to multiply it by some number. I will multiply it by 100 and plug it to emissive color. Let's do the same with another material. So open the muzzle 2 material. Also, let's save it. Delete the default parameter and add this muzzle 2 texture. Click in the empty space and blend mode, let's say mask. Connect the alpha to opacity mask. Connect this RGBA to emissive color by multiplying it by some value. I will multiply it by 100. Then we will connect it to the emissive color. And that looks good. Let's close these. Let's also fix this Lovejoy material. Delete the default parameter. There are a few different textures here that we will import. Let's import them one by one. So this is albedo. Let's import it and connect this RGBA to base color. This is AO. Connect it to ambient occlusion. This is emissive texture. Connect the RGBA to emissive color. This is metallic. So connect the RGBA of this one to the metallic. This is normal texture. So let's connect it to the normal. This is roughness. So let's connect the roughness property. And let's save it. That's all, I think. And now our turret should look fine. Let's open the turret. This is our turret skeletal mesh, and I think for now this is looking well. This is looking fine. Let's use this. So close that, and now we have our assets imported. Save all. Now let's go back to the blueprint folder. Under third person blueprints, Let's make a new blueprint here. I will use the pawn class. Let's say BP turret. And here let's add a few components. So first we will add pawn sensing component. So this will help our turret to see the target. With this pawn sensing component selected, peripheral vision angle, let's set it to 60. And also sensing interval, let's say this is 0.1. I also want to add an arrow component to make sure we have an idea of which direction is the forward direction. So let's add the arrow component. And it will also be useful later while spawning the projectiles. Now we also want to add something called posable mesh. This component will take a skeletal mesh. So with this selected, let's click here, skeletal asset, and let's drag the turret skeletal mesh here. So posable mesh allows us to adjust the bones of our skeletal mesh in game. Also, we can see that our mesh here is facing the wrong direction. So let's rotate it appropriately. When we actually rotate any bones in the blueprints or in the event graph, we will need to take care of any directions because this is facing the wrong direction. So we might have to make some adjustments. Now I will press the E key on my keyboard and we can rotate it. I will rotate it by 90 degrees. So it is facing the arrow properly. And then I will press W on my keyboard and we need to position it correctly. So from here, from perspective, I will say top and I want it to be in the center. So something like here. That looks good. I will adjust the arrow later. And then left. Let's make sure it is almost touching the floor. That is fine. We can enter the perspective mode again. Now let's just also adjust the arrow. I will go back to the left here and I will select the arrow. I want the arrow somewhere like here near the muzzle. So because we also want to use the arrow position for spawning the projectiles, so let's position it appropriately. I want the arrow somewhere like here. Now let's enter the perspective mode. If the arrow is too short, we can increase the size from here. Let's say I will increase the X values here. Oh, that is too long. Let's say 3. That is too long too. Let's say 2. That looks fine. So if you see it again, the arrow is almost in the middle here and it is at the level of the muzzle. Almost in the middle and at the level of the muzzle. Go back to the perspective mode and also we can see that we do not have any collisions here. So I will also add a collision here. I will add box collision. I want this collision to be big. And also I will drag it on this arrow component here so it detaches from it. I will enter the top mode again here and I will press the R key on my keyboard to resize the box. I want it to be big. W to move. And let's see it from the left as well. Make it big. W to move. Let's click here to disable snapping and I think this is fine. Compile, save. Let's drag it on our level and see how it looks. Oh, the collision is not blocking. So let's fix that. So with this box selected, let's say collision presets. Instead of overlap all dynamic, I will say block all dynamic. Compile, save. And it is colliding properly now. And it looks good. Now, we will rotate the turret. So our turret will be in either one of two states. It will either be searching for target or it will be attacking the target. If the target is within its vision, it will be attacking the target, else it will be searching for the target. So we need something called an enum. So let's right click here and in a blueprint, let's say enumeration. Let's say this is turret state. Open it and I will add two enumerators here. First one will be searching. Second one will be attacking. So this is like two modes for our turret. Our turret is either in the searching mode where it is looking for the target, or it is in the attacking mode where it is attacking the target. Now back in our turret blueprint and in our event graph, let's make a new variable. We will call it turret state. The type will be the enum that we just created. So it will be turret state. And when we compile it, by default, we can see that it is searching. So by default, the turret state should be searching. Let's get turret state. And every tick, we will check if the turret state is searching or attacking. And if the turret state is searching, we will execute the relevant event for searching. And if it is attacking, we will execute the relevant event for attacking. So there is a very useful node for something like that. It is called switch. So it will be switch on turret state. And we will need two custom events, one for rotate turret and one for attack. So let's make them. So I will add a custom event for rotate turret. And one more custom event for attack. Let's say turret attack. And if the mode is searching, if the state is searching, we will call rotate turret. Or if it is attacking, we will call turret attack. So that is our event take. Now let's work on this rotate function, on this rotate event. If we open the skeletal mesh, we can see that we have this bone spine. And if we rotate this bone, our turret will rotate from upside. So let's do that. And posable mesh gives us the capability to do that. So let's get the posable mesh. And before we can actually set the rotation of that bone, we also need to get the rotation of that bone, because some of the values will be from the previous rotation. So first, let's get the bone rotation. Get bone rotation by name. And the name of the bone is spine. For your skeletal mesh, it might be something different. And bone space, I want it to be in component space. Now we also need a boolean variable. Let's call it something like should turret rotate right. And if it is true, we will rotate in one direction, else we will rotate in another direction. So let's make the boolean variable. The type is boolean. And by default, it is false. And we will break the rotator. So we will get the individual x, y, and z values from this return value here for our bone rotation. And we will set this should turret rotate right variable here. We will set it to some value here, but to what value should we set it? And that depends on the z value. So let's do that. And if the z value is less than 70, and this variable is true. So if the z value is less than 70 and should turret rotate right is true, or If the Z value is smaller than -70 and this variable is not true, that is the case, then we will set should turret rotate right to true, else we will set it to false, and this OR handles it automatically. So if the Z value for this bone rotation, for this spine bone rotation is less than 70 and should turret rotate right is true, or if the Z value rotation is smaller than -70 and should turret rotate right is not true, we want this variable to be true. So it's like saying if the rotation for this bone is less than 70, go in other direction, and if the rotation for that is less than -70, go in the opposite direction. In simple words, it is like that. Now we can set the bone rotation. So let's get our possible mesh and say set bone rotation. Set bone rotation by name. The name is spine. And let's break this rotation, split this rotation pin. Bone space is component space. And we also need this value. We also need this previous value for our bone rotation. So let's get it here and break the rotator. The X and Y will be same as before. And to the Z value, we will add some number or subtract some number from it based on whether this variable is true, whether this should rotate right is true. So let's add some number. And this should be dependent on the delta seconds. So get world delta seconds, multiply this by some number. I will multiply it by 50. You can try different numbers if you want to. And we will add it to Z value. Or we will subtract it from the Z values based on the value of this should rotate right. So we will get should rotate right and we will select float. So we will select one of these numbers. We will pick one of these numbers and we will either pick A or we will pick B if should rotate right is true. So if should rotate right is true, we will pick A, else we will pick B. So we will either add some rotation or subtract some rotation. In simple words, we will ask it to either move right or left based on the value of this variable. So that is the logic for rotating the turret. Every tick, this event is being called, and whenever this event is being called, it rotates the turret by a small amount. Let's see if it works. And yes, our turret is rotating. So it is working, as we can see. If we change the direction, yes, it is still working properly. Now let's add the logic for when the turret sees the player. Before that, let's add some tag to our player. So let's go to the content folder and third person blueprints BP third person character. That is the character that we're using. And with this selected, this top level BP third person character selected, let's look for tags. And we want to add a tag here. Let's say the tag should be turret target. So this actor is a target for the turret. If the turret sees it, it will attack it. And with this selected, with this pawn sensing selected in BP turret blueprint, let's scroll down and let's add an event on C pawn. Click here. And when our turret sees a pawn, we need to check if the pawn has a tag. So let's say if actor has tag and the tag is turret target. So we need a branch, and if this pawn has this tag of turret target, that means our turret has found a target. So let's get the location of our target. So we will get the location of this pawn, get actor location, and we will promote it to a variable. We will say target location. Now, since we have found our target, we will set the turret state to attacking. And there's one more thing we need to do. We need to make sure that the turret is looking at the player. So we can rotate the spine bone again. Let's try to do that. And before we can actually rotate it, we also need to get the current rotation. So let's get the posable mesh here. And let's get the bone rotation. So this is our current bone rotation. The bone name is spine. And it will be world space. And then we can set the bone rotation. So let's set bone rotation by name. And we can split this. We can also split this. X and Y values will remain same. For the Z value, we need to find the rotation from our actor, from our turret to the target location. So let's get the turret location. We will do that by get actor location. So we can get actor location for self to get this turret location. And then we can find look at rotation. And the target location will be our target location. We can split this. And this will be the Z value. Let's see if it works. It's not working. Let's see what's wrong. Oh, we need to set the bone name. Let's check. And seems like it is facing a different direction than we want it to be. Maybe that is because we imported this mesh like that, or it might be because of other reasons, but we can fix this by subtracting 90 degrees from the Z value. And now the turret should be looking at the player. So when it is in the vision, the turret will look at the player. But we can also see one thing. When the player goes out of the vision, the turret still does not change its mode. It is still in the attacking mode. We want it to go back to the searching mode. So let's add that logic. We can make use of a timer. So let's say the time is 1 second, and if we do not see the player for 1 second, that means the player is probably out of our vision. So we can reset the turret state. Let's make a custom event. Let's say reset turret state. And this will reset this variable. It should be searching. So we will set turret state to searching if we do not see the player for 1 second. Let's promote this return value to variable. Let's say this is reset turret state timer. And before we actually set this timer, we need to make sure that there is not another timer that is already active from before. So we need to make sure that any previous timers from this from this event any previous timers are cleared, because this event fires again and again. So before we actually set this timer, we need to make sure that any other timer that might have been set is cleared. So let's do that. We will get this reset turret state timer and we will say clear and invalidate. So we will clear and invalidate timer by handle. Now let's see if the turret goes back to the searching state. So yeah, the turret does go back to the searching state, and if we go into its vision, it looks at us. And it is in its attacking state. Now let's add the attack logic. So let's drag this attack event a little bit, make some space for it, and this place looks fine. Now for the attack, we need the turret to attack a few times. So for example, the turret attacks 3 times in a row and then waits for a while, then it attacks 3 times in a row again, then waits for a while, and so on. And we also need to make sure that there is some delay between individual attacks as well. So for example, if the turret is attacking 3 times, there should be slight delay between 1, 2, 3 attacks. And we want to be able to adjust those delays, and also we want to be able to adjust the number of attacks the turret does in a row. So let's make a few variables here. As we know that this turret attack is going to be fired again and again when the state is attacking, we need to make sure that when we are already attacking, we do not fire this, we do not execute this logic again. So we need a variable is attacking. By default, this is false. And if we are not already attacking, then we can attack. Now we need a branch. And also let's set this is attacking to true, because now we are attacking. Now while we are implementing this for testing, for attacking, let's just say we just print attack. In a while we will add a projectile, but for now let's just say we will print something like attack. And since we have attacked once already, we need some time before we do the next attack. So we will add a delay node here. And for this duration, let's say we will make a new variable. It will be float. And let's say the name should be delay between individual attacks in seconds. Compile, and by default, let's say this should be 0.15. Let's get it and connect it here. And now we also need to keep track of the number of attacks we have done. So to do that, let's make another variable. Let's get it, and let's increment it. Actually, this should not be float. Delete it, and the type should be integer. Now let's increment it. Increment int. And then we can check if we have reached the maximum number of attacks in a row. Then we can reset this number of attacks and also wait a little longer. So let's make another variable. I will call it attack frequency. This is the number of times the turret attacks in a row and waits. By default, I will say this should be something like 3. And we need to see if this number, the number of attacks already done, is greater than or equal to our frequency. We need a branch. So if we are still attacking and we have not yet done the maximum number of attacks, then we will just go ahead and reset the is attacking variable. We will set is attacking to false. But if we have exhausted the number of attempts that we have, number of attacks that we have, and we need to wait a little, we need to wait for some time before attacking again, then let's reset this number of attacks here. We will set it to 0. Then we will wait for some time. And this will be a new delay. Let's say this is a new variable. This will be a float. Let's say delay between multiple attacks in seconds. And we need to make sure that this is both of these delays are smaller than this here. So because this timer resets the turret state in 1 second if it does not see the target, we need to make sure that these delays are actually less than that. So let's say 0.9. We will get it and plug it here. And then we can reset this is attacking variable too. Now we can see that when we come in the turret's vision, it attacks for 3 times, waits for a while, then attacks for 3 times. And between those attacks also there is a delay. Now let's add the projectile. So let's add a new blueprint here. We will use the actor class. Let's say this is BP projectile. Open it. Let's add a sphere. Let's select it, and with this lock icon selected, let's resize it to 0.1. And also let's go to the event graph. At begin play, we want this projectile to last only 5 seconds. So let's set the lifespan 5 seconds. And if it actually overlaps before that, then also we want this projectile to be destroyed. So if you do not have this actor begin overlap, let's delete it. Let's delete that too. We can get it from here. From override, if we click this override, we can get actor begin overlap. And if the other actor is the turret target, so we can use actor has tag turret target. If this the other actor has a tag of turret target, then we can destroy the projectile. Also, with this sphere selected, let's say physics. We want to simulate physics. And gravity. We do not want gravity, so we will disable gravity. And collision presets. Let's say custom. And the collision enabled should be query and physics. That is correct, but it should not be block. I will select it all to overlap. Compile, save. Let's also make a new material for our projectile. I will say M projectile. Open it. Let's hold 3 on the keyboard and left click. It will get a constant 3 vector. Double click here. I want a dark yellow color. So I want something dark yellow. Oh, reddish. This will work. And I want to multiply it by some value. I'll multiply it by 100. Connect it to the emissive color. That looks good. Back in the projectile, I will use the new material that we created. And this is looking fine. Now back in our turret blueprint, we will remove this print string here. Let's get some space. And we want to spawn actor by class. Spawn actor from class. Class is the projectile class that we just made. Let's split this pin, and we want to get the sphere, and we want to set physics linear velocity. Now we will make use of the arrow component that we added earlier. So let's get the arrow, and we need the arrow's location. So we will get world location, and we need direction from the arrow to the target. So we can get unit direction vector from the arrow's location to the target location. So we could directly plug it here, and our projectile will spawn from our arrow's position. Our projectile would spawn from here. If we do that, I want the projectile to spawn something from here, somewhere from here. So I will add some value to it along this direction. So along this unit direction, I will add some value to it. So let's multiply this by something like 60. If your mesh is different for this, for you, this number can be different. So we will change this pin to float and multiply it by 60. Then I will add it to the world location of the arrow here. Then we can connect it to the transform location. So that is where our projectile will spawn from. Now we also need to set the velocity of that projectile. So along this direction, we need to set some number. So let's multiply this unit direction vector by 3000. Convert this pin to float, 3000, and connect it to the velocity. So from the arrow's position to the target location, we have this unit direction, and along that direction, we want to set the speed, we want to set the velocity of our projectile. Let's see if it works. And yeah, seems like it is working. If we increase the frequency from 3, let's say make it 8. And let me also change the turret position. And this is our turret. When we come into its vision, it starts attacking us, and after attacking for like 8 times, it waits for a while and then attacks again. Let's select all of these and comment it. Also, we have set these values here to 70 in rotate turret. We have set these values here to 70 and negative 70 because the vision of our pan sensing component, the peripheral vision angle is 60. So we want this rotation angle to be slightly more than the vision, so it looks a little bit better. So that is why we have set this number here to 70, because we want it to be slightly larger than the vision angle. So that is how we can make a turret in Unreal Engine. If you like the video, give it a thumbs up and leave your feedback in the comments. I will see you in the next one. Thank you.